So we left off yesterday on page 23, and I asked you to give it a try. We didn't necessarily go. I didn't discuss, right? Really, what determining what's more likely to happen, but really, there's no new concepts here. It's just, right, to find out what's more likely to happen, we use the probabilities, and whichever one is the higher probability, that just means, right, that event is a higher chance of happening. Right, so I'm going to go through some of these examples here. The odds of coming into contact with hornets. We're right over there? We're good? So we're given the odds of being attacked by a shark and the odds of being in contact with hornets. So we want to state the probability of being attacked by a shark, right? So this is just an odds to probability question. Right, so our total for our shark, right, is we add these two up together, right? So it's 1 plus 3,748,067, right? So that gives us 68, right? So that's our total. And now we want the probability of being attacked by a shark. Well, the odds of being attacked by a shark, right? So this is the odds of being attacked. So that means the number listed first is number of ways or times being attacked, right? So that is, so the probability of attack would be 1 over our total, right, which is 3,748,068. Right, and we do the same thing, the probability of being attacked by hornets, right? So in this, right, we want to check our odds of coming into contact with hornets, right? So this means that this is odds in favor of coming into contact with hornets. So that is what we want in our numerator. So the probability of being attacked by hornets would be 1 over the total, right, which would be, we're adding up, right? So for odds, these two numbers always add up to our total. Always. Right? So this would be our probability. Right? So we have our two probabilities now. Right? So it's hard to compare when we're given just odds, what's more likely to happen. We can. In this case, it's relatively more simpler than in some cases because the numbers are so off, right? So the odds of coming into contact with the hornet is 1 in 54,000-ish, right? And the odds of being attacked by a shark is 1 in 3.7 million, right? So the odds are a lot lower for hornets. But if we didn't see that, right, we clearly see it here, right? So, and the key thing sometimes, again, our numerator, like the total we're dealing with, is very, very different, right? So which one, just by looking at the fractions, which one do you think would be more likely to happen? Being attacked by a shark or being attacked by a hornet? Yeah, because this number is smaller. But if you didn't know, right, sometimes the denominators, right, comparing fractions can be a little bit difficult, right? So it's just a good idea to convert. Again, in this case, you may have seen it, right? But in this case, if we convert to a decimal, right, it's 0.00018. I'll just leave it at that, right? And this is per percent, right? If we times this by 100, we move that decimal place over 2 places to the right. So it's 0.0018%. So it's still slim, right? But for the shark, it's even smaller. So 137. If I plug this into my calculator, I get 00. So there's 6 zeros now. 266. So this is 0.000026%. So very slim for shark, right? So which is more likely to happen, right? Say being attacked by hornets is more likely to happen. Because, let's say, the probability of being attacked by hornets is greater than that of sharks. Right, so for this example here, the odds are a little more closer together. It's not as, the numbers aren't as far apart. So we have here the odds of Xavier being late is 4 to 9, while the odds of Nina being late is 5 to 14. Which student is more likely to be late? Right, so if we want to convert our odds to probability, right? So we have, let's say the probability, let's do Xavier first. So I'll just do the probability that Xavier's late, right? So this is our numerator, 4 of him being late, over the total, which is 4 plus 9, right? So that would be 4 over 13. And if we do the same for Nina, right? Hers is 5 over 5 plus 14, right? Because so Xavier's late 4 out of 9, 4 out of 9 times, and Nina's late. 4 times she is late, and 9 times she's not, or Xavier is. And then for Nina, 5 times she is late, and 14 times she's not, right? So we get the total, and it's 5 out of 19. Right, so in this case, it's not as easy to know, right, is 4 over 13 greater than 5 over 19? Like it's not as obvious when comparing fractions which one which one is greater. So in this case, this would be a good idea to convert to a decimal. So if I go 4 divided by 13, right, that gives me 0.3077. And for Nina, it is 5 divided by 19. That gives me 0, right? So it was relatively close. But now we can see that which one is greater, so 2. Right, so who's more likely to be late then, based on these probabilities? Yes. Which student is more likely to be late? Xavier. And why? Yeah, exactly, because the probability of Xavier being late is higher than the probability of Nina being late. Right, so Xavier is more likely to be late since probability is greater. Right, so for these questions, just make sure, right, so in this case, we calculate the probabilities and it asks which student is more likely to be late. But instead, we could have asked which student is more likely to not be late. And in that case, right, it would be Nina, because she has a lower probability of being late. So just make sure that you read the question and what it's asking. Any questions on these two examples? So I will give you some time to work through well, I guess I did. Yeah, 22 to 23. No, I didn't. Okay. I'll give you some time to work on 24 and 25. So we'll see where we're at in about 10, 15 minutes. And then I think we're going to move on to a new concept looking at theoretical versus experimental probability. So I want to give you some time to, if you have any questions, you can ask. Right? Because again, we had our AC yesterday, so if that brought up any questions, now is the time to ask. But you can work on question 20 or pages 24 to 25, and then we'll regroup in about 10, 15 minutes.